Okay, here we go. 7-3. Yep.
You want to take a picture? No. Wait, is it just front and back? Yeah. Running out of room as I know, but you're running out of room.
Okay. Still going to hypothesis test for the population mean. That hasn't changed. Okay. The difference is coming in right here. Small sample, under 30. So if it's under 30, before we can even do the problem, the population must be given as normal or we can't do it. So, if we are doing mean, small sample, normal population, the difference between yesterday and today, yesterday was the z-score, the z-table, today is going to be the t-table. So these are t values.
Are there only going to be 4 sections in this chapter?
Yep. Well, the first one was kind of the general overview, and then the 4 hypothesis testing, so 5, yeah. So we will finish the chapter on Tuesday. All right, so let's read the t-table first. So our first example is going to be reading the t-table. Then I'm going to take you through one hypothesis test, and then you're going to be done. Because you learned how to do it yesterday. All right. Reading the t-table. The directions are going to ask you to find the critical value. That's the vocabulary term that says, oh, which table should I be using for this critical value? It's critical because it separates shaded from unshaded. So find the critical value. So the ha is going to have a less than. The sample size is going to be 14. The alpha is going to be 0.01. The claim is going to have a mu, and the population is normal. So instead of writing all that out individually. So a mu with a small sample for normal tells us t. So we know we're going to use the t-table. Just like yesterday, your rejection region is determined by the ha. With a less than, it's over here. It's equal to the alpha value. And we want this t value. Well, if you grab your t-table, on mine. Here. Okay, if you look on the left here, what is this headed, the heading here for this column? Degrees of freedom again. So how do we get degrees of freedom just from last chapter?
N-1.
N-1. So GF is still N-1. So we are going down to 13 degrees of freedom. And how much area do we have behind us? 0.01. So we've got one tail with 0.1 is here. And we're going down to 13. 2.650. Take a look at your graph. Does it make sense that this is 2.650?
Negative.
Negative. You've got to supply the negative, because remember, 0 is still in the middle. It's still a normal curve. So this is negative 2.650. Does that make sense? Okay. Try another one. So this next one, the ha has a greater than, n is 9, alpha is 0.05, claim has a mu, and normal population. So the mean, small sample, normal, those three things together tell us we're using the t-table. Greater than 5%. And we're looking for this critical t. So use your df and your one tail area. So df is 8 and one tail with 5%. One tail 05. 1.860.
Yeah.
Positive or negative?
Positive.
Positive. I forgot the number 8. What did I say?
1.860.
860. Okay. Okay, and then our last one is that two-tailed business. N is 16. Alpha 01. Claim has a mean, normally distributed. Point, what's going to be in each tail? 0.005. DF is 15. What are you thinking there? Let's see. 0.1. What's common sense telling you to do there? Before I tell you if you're right or wrong. You can look it up two different ways. You can look up and you can see they're in the same spot. We've got two tails with 1%. So you can go to the two tails and get the total that's in the two tails. Or you could do the one tail, which has a 0.005. So they're both at the same spot. So whichever one you want to look up. And then degrees of freedom was how much? 15? So 2.947. And then a negative 2.947. Okay. The steps are identical to what we did yesterday, except we're doing T's instead of Z's, so I don't feel the need to write out those 5 steps again. I'm just going to say that the steps are the same. Just using T's. Instead of Z values. Oh, we'll go through one.
How long do you think
It's about the same examples as yesterday. You know, where you write out the claim, and then we do the 5 steps, the graph, and I don't think you'll need more than one to feel confident, if you did yesterday. Okay, so the claim being made is that the mean cost to insure a truck, doesn't tell me what state this is in, is at least $875. So you take a sample of 9 trucks, you find that the mean is 825. With standard deviation, $62. Insurance costs are normally distributed. Test this at 1%. Okay, so the claim, again, what variable are we doing statistics on? We are doing the mean cost. So when we rewrite the claim, we want that symbol. Mean cost at least $875. What's our math symbol for at least? Greater than or equal to $875, making the claim the ho. The ha then will be that the mean cost is actually less than $875. Okay. Because I'm dealing with means, I know there's going to be either a z or a t involved here. What's going to tell me z or t? The sample size, normally distributed with this S value given. That all says T. So, we know it's normal. We're going to find the critical T first. So my rejection region, determined by the ha, is in the left tail. 1% shaded. And before I even look it up, I'm going to put the negative on there right now, because I'm in the left tail. I know that's going to be negative, but the table's not going to tell me that. So look up your degrees of freedom on the T table with the 1% in one tail. What is our critical value? 7 is wrong. Close though. I'm agreeing with negative 2.896. Okay. Now we take our sample, turn it into a t-score. Nothing in that formula changes. We're still going to go sample mean minus population mean divided by the standard deviation over the square root of the sample size. So, the t-score for 825 is 825 minus 875. Standard deviation was 62. Square root of 9. negative something. Anybody? Okay. Where's negative 2.42 on this number line? Are you into the shaded or are you staying in the light unshaded? Right about here. We're approaching it, but we're not there yet. So because I'm in the unshaded, what's our conclusion we make? Fail to reject the hoe. Use that poster in front. Follow the correct branch down. What are we saying about that claim? Not enough evidence to say it's false. Could be true, might not be true. Need more data. Okay. Page 337, 21, 23 are definitely T's, and then these last four, they're mixed together with Z's. So you're going to have to decide whether you'll be doing Z's or T's. So 29 to 32 is a mixed bag.
Wait, are we just saying Z or T?
Oh no, you're doing the whole hypothesis test. Hopefully you picked the right one. So there's 6 problems on the homework.
337?
I believe that's what I have written down. You trying to say that middle digit, you can't tell what that is?
I'm pretty sure it's a 3, but.
Yeah.
It could be like weird, oh, yeah, weird 8. A
8?
Bad 0, it could be 7.
Oh my gosh. That just says 3 all around.
Oh, that's
Got it.
what it's up for.